to lessons 3.1 and 3.2 for honors geometry. So today we're going to go over two different lessons. The first is going to be talking about identifying pairs of lines and angles, and then we're going to move on to parallel lines and transversals. So moving on to the first part, parallel lines and skew lines. So parallel lines, you guys have dealt with these before. I know that for a fact. So remember, parallel lines are considered to be lines that are coplanar and do not intersect. And if you remember back in your algebra days when you were coming up with an equation of a line, we had the equation of a line is y equals mx plus b, where m is your slope. So for parallel lines, your slopes will be equal. So that means that your slope of one line is going to equal the slope of a second line. So now we're going to move on to skew lines. So this is a terminology that may be new for you. Skew lines are lines that are not coplanar and do not intersect. So they're similar to parallel lines in the fact that they don't intersect either. However, they are not coplanar. That means that they do not lie in the same plane. So let's take a look at the figure here. We've got three lines in our figure, or in our diagram. Lines N and P are parallel lines. We can see that they are in the same plane and they are parallel to each other. They do not intersect. And then we've got this line S that is sticking through. It looks like it's piercing the plane. Line S is skew to both lines N and P. It is not going to intersect either of those two lines. It would be similar to if you were to take your notepad that you've got there and draw two lines on it, and then take your pencil and place it so that it would look like it's piercing through your notebook. That pencil would be a skew line to the lines that you just drew. So moving on to the next slide, we've got lots more postulates and theorems that we're going to be talking about today. So the first postulate that we're going to go over is the parallel postulate. And this states that if there is a line and a point not on the line, then there is exactly one line through that point that will be parallel to the given line. So let's see what exactly that we're talking about here. We've got a line and a point A that is not on that line. There is only one line that can go through point A that is parallel. And if we rotate this around, we can see any other line that goes through that point would intersect. There is only one line that can go through point A that is parallel. So now let's take a look at postulate 14, the perpendicular postulate. This is similar to the parallel postulate in that we're still dealing with a line and a point. And what the perpendicular postulate says is that if there is a line and a point not on the line, then there's exactly one line through the point that will be perpendicular to that given line. So again, very similar in wording to what we just talked about for the parallel postulate. So let's again see what it is that we're seeing. So we've got a line, we've got point B not on that line. There will be exactly one line that goes through point B that is perpendicular to the line. So right now we've got the line that is parallel. If we rotate this around, we'll see there is only one line that is perpendicular. So as many times as we want to rotate that around, we'll see there's only one that will be perpendicular, and that's where it stops at right now.